We're going to look at doing density problems. Please note at the top of the page, density is mass over volume. Mass is usually done in grams, and the volume can be cubic centimeters, like we've had in a couple of our labs, or it can be in milliliters. That's also okay. Just letters, D equals M over V. There are two other forms of this same equation. They've just been rearranged, but you can solve to find out what the volume is. That would be the mass over the density. And you can solve for what the mass is. That can be the volume over the density. So, one of the things that's really helpful when you're doing a problem is to annotate the question. What that means is you read the question, but you label it as well. In this case, we're looking for things like the density, the mass, the volume. So, for example, right here, 52.457 grams. Well, that's going to be my mass. So I label it with an M. The 13.5 cubic centimeters, it says volume. So there's my V. Those are the two numbers it gave me in the problem. It wants to know the density. Well, that's my D. And I'm going to put a little question mark by it just to indicate that's what I'm trying to find out. Now, please note the directions say show the equation used. So here's my equation. D equals M over V. Now it's just a matter of plugging in the numbers. D equals the mass, 52.457, over the volume, 13.5 cubic centimeters. Get my calculator. Do the 52.457, divide by the 13.5, and I basically come out with 3.89. There are more digits. That's good enough. I have grams. I have cubic centimeters. I didn't do anything with them. They're just the units. And there's my answer. Okay? That's the idea, basically, of doing a density problem. Number 2, I have a rectangular block of copper, and it weighs 1,896 grams. That is my mass. Anytime I see the grams, that's mass. The only other numbers it gives me is it says the dimensions of the block. Well, that's basically a length and a width and a height. They did not give me the volume. The density, again, is what we're trying to find out. So I'm going to put a little question mark there. Well, this is similar to what we did with the cardboard lab. Volume is length times width times height. So my volume is going to be the 8.4 centimeters times the 5.6 centimeters times the 4.5 centimeters. And because I have centimeter times centimeter times centimeter, I'm going to get centimeters cubed. So my volume comes out to 111.68 cubic centimeters. It might have more digits on my calculator, but that's good enough. So, like the problem above it, D equals M over V. There's my equation. By the way, the equation doesn't have numbers already plugged in. It just has the equation. Okay, now I'm going to plug them in. So my mass, 1,896 grams. My volume, 211.68 cubic centimeters. My density came out 8.96 grams per cubic centimeters. So there's one in which I had to do a calculation of the volume first before I could do the density. In number 3, again, I don't seem to have everything I need. There's my grams, so that's my mass. But now I've got water, a couple of waters. It was at 45.6, it went to 49.2. This is kind of like a couple of our density labs, one with the rocks and one that you did with the metal cylinders. So I'm just going to label this as my H2O before and my H2O after. And while it's not on the sheet, I remember from my lab that the volume is simply going to be the H2O after subtract the H2O before. In other words, to get a positive number, because it went up after I put in this case, the iron. So plug my numbers in. Let's see, 49.1 milliliter, subtract 45.6 milliliter, and it comes out 3.5 milliliter. So again, writing my equation, D equals M over V, mass over volume, plug them in. My mass was 27.56 grams. My volume I just found to be 3.5 milliliters. I'm just going to leave it in milliliters in this case. That's okay. In our labs, we often changed it to cubic centimeters because maybe we wanted to compare it to something else that was already in cubic centimeters, but it doesn't have to be written that way. Do the division, and I come out with 7.87 grams per milliliter. And so there's the density for number 3. Any questions so far? All right, number 4, it says what volume? So this time I want to find out the volume. There's my grams, so that's a mass. And here's my density. Grams per cubic centimeter. So if I start with the density equation, in other words, you don't necessarily have to have everything memorized. If I started with my one equation and then basically multiplied both sides by V, I would have the volume times the density equals the mass, because here they would cancel. And then, since what I really want is the volume, if I then divided both sides, they would cancel here, and now I have my volume equation. The volume is the mass over the density, and note, essentially all that happened was I switched the D and the V. So now I can plug in my numbers. I have my equation, 2,500 grams, 10.5 grams per cubic centimeter. Please note the grams cancel, but my answer will be in cubic centimeters, which is a volume unit of measure. Any questions on that one? Okay, and the last one, this time I want the mass. This is cubic centimeters, so that's the volume. And again, this one's the density. Right up here, I had V times D equals M, so my equation to find mass, m equals v times d. So now plugging things in, volume 350 cubic centimeters times the density 2.336 grams per cubic centimeter. Note, the cubic centimeters get canceled and I get an answer in grams. Now on this paper at the top, I have listed the equation in all its forms. Generally speaking, when we have equations like this, we do not list every form of the equation that you might need. We will give you the principal one, and then it's up to you to be able to rearrange things to solve for whatever we need at the time. It won't always be exactly the way the equation appears, such as in questions 4 and 5. But certainly, more often than not, it will be just like the equation looks. It's just that sometimes you'll be expected to do variations of that. Are there any questions? Did this help? All right then. So